Hi everyone, thank you for joining me in the final tutorial session of 15 days of SQL. If you're new here, hi, I'm Akriti. I work in the data domain and work mainly with Python and SQL. I am also a part-time content creator on Twitter, and now I'm just getting started here on YouTube. So thank you for joining me in my initial days of YouTube. If you've been there for quite some time, you might get used to these sentences. So in case that is the case, thanks for being back. Today we'll be discussing one of the most feared about concepts of SQL, which is window functions. Over the past 2 days, we have discussed two window functions, that is row number, and yesterday we discussed about ranking window functions. Those were rank and dense rank, correct? If you need a little bit more context as what they were, and they're not significant for this lecture, they're not a prerequisite. However, you might want to check them out because they are very, very frequently used and essential while solving interview questions or in your day-to-day job. This is the 15 Days of SQL playlist and I welcome you here. Let's get started. Today we'll be focusing on two more window functions. They often work side by side, but it is okay if you use one just as is if the situation demands that. But mostly wherever I've seen, they are required together. But there have been instances, a few, where they are singularly used. Those are lag and lead. Now what they do is, oftentimes what happens is, we need to compare a value with a previous value. That is the condition whether you are calculating, say, the month over month. So what was the increase in your revenue from last month? What do you need to do? You need to compare your current month's revenue from your previous month's revenue, correct? So you need to go up the table for the same column. Now our usual functions don't have anything as such which would let you select just the column and a row above it. For that we need to make use of Windows functions lag and lead. So what happens is, in case you have a table and you need to access not just one row but a row above it as well, so you'd use lag, correct? Because the English literal meaning of lag is behind and the lead is ahead. What window functions do is they define a window, correct, which is in relation to the current calling row which is currently referenced, and it also works over a group of rows which are somehow connected to that row for calculating some value for that particular row. In this case, what the value we'd be calculating is the previous row's value. For my particular row, my row number 2, what I'd be trying to calculate and find out using my window function is the value of row 1. So now the window function itself is dealing with multiple rows, but for a particular row, to get an output for a particular row. How are window functions different from aggregate functions which also work on a group of rows is that the work which they do is not for groups. The rows maintain their individual identity and all of the outputs are for each of the rows. While trying to generate the output for that particular row, the lag, lead functions or any window function might have to consider multiple rows in order to calculate it. However, they do not consider the entire group as one and then calculate the equivalent value. No, they have each and every row and they calculate the value per row based on some other rows. That's how they are different from aggregate functions. Now what the concept of lag and lead is that they help you find out the preceding or the following value from a certain column. What is the syntax is? Simple syntax of any window function is that you mention the function, then you say over, and then you define your window. Your window can have a partition, so you can divide whether your window is created within subgroups or not. And it also has an order by clause, which will specify that in which order the window should be created. We started with a very specific small example of creating a running total. So in that, the window which we specified was ordered by some ranking. So what it did was, it started from the topmost row and then expanded as the order demanded, and got the sum value of this and the previous whatever rows have occurred in order to get the running total. So what window functions would do is, they will first create a partition in case you need your values within subgroups. They can, however, work with the entire dataset at once also, but in case you want it categorically, you would have to first create a partition. So for each category, now within the category, the windows would be created. Within the category, it will order the rows by some condition and then create the window. After creating the window, this function, which was specified earlier, would be performed on each window for each row, and then the equivalent result for each row would be generated and stored for the following column name, which in this case is lag. So let's try to run this query. Okay, I won't take the rest of it. Let's just first run it and see how it works, and then we'll get the logic behind it. What we're trying to do here is, we are creating the partition by start terminal. That is, for each start terminal value, it will consider it separately. Okay, so it won't mix. So like, well, this was a start terminal, it was a group of values, group of rows within that start terminal, and this was the first row to occur. So since it was the first row, it did not have any row above it, correct? So it did not have any lag value. Similarly, the last row won't have any lead value, because within that category there is no next row to reference. Why do we use the order by clause? So if you don't specify in which order the values should be arranged, then how would SQL be able to determine that what is the value ahead and what is the value after? That could be just random rows, and there won't be any order which they are following. So it can consider or reference the value lagging and leading. So we gave an order, it gave us all of the values order wise. It ordered it by the name, by the values of duration seconds per start terminal. And now for each duration seconds, it is trying to calculate the value before it and after it. So for the first duration seconds, there was nothing ahead. There was nothing before, but there was something after. So 3 was after, so the lead is 3. Now for this row, 3 was before it, correct? And 8 is after it. So 3, 8. Now this is 8 and 3 is before it and 17 is after it. So lag is 3 and lead is 17. Next is the row 17, which has 8 before it and 21 after it. So the lag value is 8 and lead value is 21. Cool. And in this way only, it orders the values and always gives us the value before it and after it. This is the whole functionality of how lag and lead work. The syntax being, you'd have to first say from which column you want the lag and lead to be performed. So in this case, I wanted to get the lagging value and the leading value from the column duration seconds. So I specified it. Next, you need to tell how many values ahead do you want it. So if I want 2 values before, 2 values after, so I would have to specify the number. Here you wanted the immediately preceding and succeeding value, that is 1 value up, 1 value down. I can totally make this 2 value up and 2 value down. It is up to me. And then you will see the difference in results. Now you see 2 values above it, it had nothing, but 2 values after it, it had 8. So lag is nothing, lead is 8. Now for this 3, 2 values above, it had nothing, but two values after it had 17. So lag is nothing, lead is 17. For 8, you had two values above was 3 and two rows below was 21. So 3 and 21 as the lag and lead respectively. Next we have 17. Two values above was 3 and two values below was 40. So we have 3 and 40 as the lag and lead. And similarly for everything, however you want the succeeding and preceding values to be calculated or selected, you can specify by what skip or how many rows to skip before you get the value. So I wanted 2 rows above. I can want 3 rows, 5 rows, 7 rows, 10 rows, as much as I want. I just have to change this parameter, the second parameter of the lag and lead function, which takes the number of rows above, the number of values above the current considered row to calculate the lagging and the leading value. Again, lag and lead would take two arguments, first being the column on which they need to be operated on, the column from which you need the preceding and succeeding value. Next, by how many rows do you need the value to succeed or precede? That number you would give as the second parameter. And then, like we have been defining windows from the past two lectures, we'd define our window as over, and then within a parenthesis we'll tell the window which we want is. We want to partition it by start terminal, that is have individual values, individual videos, sorry, not videos, windows for different start terminal values. And how do you need the values to be arranged in order to create the immediately succeeding and preceding values? Is you want them to be arranged by duration of seconds. This could be anything. I could do it by start time, and then from start time it will say what was the duration seconds before it, what was the duration seconds after it. If I order it by start time, it is on my hand how I need to order my windows. The column which I want the value from would be specified here. The column which I want to order from would be specified here. Okay, and this is one concept. If you have any doubts regarding it, feel free to post it in the chat. I am taking a look at it. For in case you want to, I mean, this is highly recommended that you practice it side by side. So here's the tutorial which I have been showing you and the database which I have been accessing. The code is available here. Okay, and so now you have seen that lag and lead are two functions. What you'd see is these two have this in common, right? The window which you have created, the window which you have created, the window which you have defined for the functions is same. So do you think it makes sense to write the same thing again and again when the whole point of writing code was to remove the redundancy and to avoid multiple, repeated work? So why would we want to write this window knowing that it is going to be same? In case it is going to be same, why should we write it again and again? So for that we have another concept, very convenient concept called window alias. What it does is, instead of writing the same window again and again and again, you just use a window name. Okay, you just use a window name, and then at the end of the code you define what that window was. Okay, so I will take this from here, I don't want it. Okay, and I'll give it a window name, say lag window or some window, my window. Okay, my window. And neither do I want this, so I would specify, I know that I don't need it, so my window. So in place of writing the same thing again and again in it's long, right? You wouldn't want to make your code difficult to read by writing the same thing again and again if it can be replaced. Now, once you have written my window, at the end of it, write window. Okay, and then give the name of the window which you have used as a part of your code, which is my window in this case, as, right? And then you give the specifications of your window that I want to partition by start terminal, I want the grouping to happen by start terminal, and within that group how the windows would be ordered is I want it to be ordered by duration seconds. Cool. And now run it. Now don't you think the code is easier, much pleasant to look at than when it was cluttered with the windows? And this is just a condition where we were just using two windows, two instances of the same window. When in practical use, you'd be using multiple windows, multiple calculations, and then using the same thing again and again, writing the same piece of code again and again, makes the code really difficult to read, debug, manage, and collaborate with. So it's always better to modularize it if it is possible. Here it was by defining a window alias. This is called a window alias. You have learnt about column alias, where we were creating a new column and then we were giving it a name. We have also used it here. We created a new window based on our window functions and then gave it a new name as this column alias. We have used subquery alias when we were fetching from another query and then we were trying to use that as our data source. We gave it. We have given alias when we were referencing multiple data tables during joins. We have always given them alias for it to make it convenient to refer the columns through that alias name later. Similarly, we can have window alias where you just tell the window name, and then based on that window name, it calculates it. At the end of the code, you'd have to just tell what the window specifications are, like this: window, name of the window, as, and then in brackets whatever the specifications are. Cool. I hope this was clear. And hi Chinmay, yeah, you can go to my channel and you'd find a 15 days of SQL playlist. There the episode 11th and 12th would be window functions, so feel free to check that out, where we have started with the basic understanding of what window functions are, where they're used, and some basic window functions like row number, rank, and dense rank, and now lag lead. We have another window function here, which is entile. So oftentimes we have to visualize or get an idea of what is the percentile within our data, correct? How the values are arranged and what is the percentile value of a particular row. What is percentile is? What is the fraction? I mean, it is similar to rank, but it is expressed as a form of percent in a way that the highest value gets 100 percentile and then everything is like relative to that 100%. So that's how percentiles work, and you can give the percentile value in the same way as you have written several other window functions. What it is you write the function name and then you write over and then you define your window, which is in two steps. If you want to specify how you want to partition it, that is divide into further subgroups, you have to say partition by some column name. Next, within that subgroup, how you want it to be ordered. Okay, even when there is no subgroup, you still would want to order it in order to calculate anything, rank or row number or the lagging, preceding, leading, succeeding value, and now the percentile. So entile is the function which we use to get the percentile from a particular column value. It will consider all of the values in that particular column or in that particular subgroup within that column, and then it will give the percentile for your particular row. So again, how the window function is getting implemented here is, for your particular row value, is the output getting calculated. However, how the output is getting calculated is, It is considering all of the values and then trying to calculate a percentile, which is the output for your particular row. So the entity as a row is maintained. The row is a separate identity. However, for performing the calculation for that entity, we are considering a whole bunch of other rows to calculate the output for that particular row. Cool. Entile is the function to calculate the percentile, and it takes one parameter, that is how many buckets. What are buckets? How do you want the percentile to be? Correct? Let's try to get it and see how we Now what it is doing is the window function is first partitioning by start terminal. All of the values of start terminal will have different uh, percentile calculation, and how it wants to order it. So it wants to order it by duration seconds. The ordering here means that how the percentile is getting calculated. So the lowest value of duration seconds would be in the lowest percentile, and the highest value of duration seconds within that subgroup would be in the highest percentile. I'll show you. Oh, we're still not there yet. I think if we filter it a bit, maybe we'll get it. So I'll filter it because I want to limit my value scope to show you where the percentile starts and where it ends. That's why I'm trying to get a small subset of values. Now you see, for 3100 we have the smallest value as 74 seconds, and it is in the percentile quartile 1. Cool. Why is it quartile? Because it is considering 4 buckets. So everything from the 0 to 25 percentile would be in one bucket. Everything from 26 percentile to 50 percentile would be in one bucket. Everything in 51 percentile to 75 percentile would be in one bucket. And everything after that, 76 percentile to 100 percentile, would be in another bucket. Here we have lowest as 74, it is in the first quartile, and the highest as 3340, it is in the highest quartile. That is, what we are trying to do here is, we have just divided data in the number of buckets. So here it was 4. So based on their value, how small it is or how big it is getting distributed into 4 buckets. So if it is really small, it is getting stored in the first bucket. If it is a little bit more than that, it's getting stored in the second bucket. If it's even more than that, and even more than the 50% value, then it'll get stored in the third bucket. And if it is amongst the highest values, then it will get stored in the fourth and final bucket. When we have the buckets as 5, you see, for the same duration seconds, now we have defined that we want 5 buckets. So it has tried to, now you see, 4 values belong to the first quintile, 3 values belong to the second quintile, 3 values belong to the third quintile, and finally 3 other values belong to the fourth quintile. And since it had 5 buckets, so each subgroup was assigned to 5 buckets. So for the second type of row, second type of column, which had 5 buckets, it also has the bucket number 5 for that particular start terminal. It also has 3 values in the 5th bucket. Here we also had a bucket size of 100, that is, within that start terminal we tried to assign 100 buckets. We only had 16 values here, so it was only able to assign 16 buckets. Now once start terminal 31,000 ends, that partition has ended, and all of the values get refreshed and recalculated for the next bucket, which is 31,001. Again, we'll try to calculate for the first column how to assign our values to 4 separate buckets, then for the second column how to assign them to 5 separate buckets, and then in the third column how to assign them to 6 separate buckets. Cool. I hope this was clear and it was helpful in some way. Tomorrow we'll be Yeah, Sayed. SQL is a database thing, and thank you for asking that. You can start with the first video of this series, where we have discussed what is SQL and why do we even need to use it. So, thanks for that question. I hope that video will answer your question. And yeah, for all of those few who made through this entire 30-minute, 25-minute long video, thank you so much. I am so proud of you. And tomorrow we'd be starting implementing these concepts which we have gathered through these 13 days. So, in case there's some video which you have not covered yet, please try to eat the frog and complete it till tomorrow, so we are able to actually practice and get our portfolios warmed up through case studies and actual implementations of those concepts. I hope this added some value to your data analysis journey. For more such data analysis content, feel free to subscribe me here and connect with me on Twitter. Yes, I will be covering case study, Manish. I'll be covering it for the next two videos. Same time, it'll go live at the same time. And thank you all for joining. I hope you had a nice time. Bye.